We are looking into space, towards a galaxy, a giant galaxy, 500 billion light years away from us. Sorry, 500 billion kilometers away from us. Very big galaxy which was suspected to host a supermassive black hole in the very center. 101 years ago, someone discovered a streak of light, which is plasma shooting out of the center of the Milky Way, marking the supermassive black hole. I never believed that this black hole was as big as people said, until we saw that. This is the nucleus of the galaxy M87, and this is the first ever image of a black hole. You have probably seen many images of black holes before, but they were all simulations or animations. And this is so precious to all of us, because this one is finally real. What you're looking at actually looks like a ring of fire. And it's actually created by the force of gravity, by the deformation of space-time, where light actually goes around a black hole, almost in a circle. And that creates that circle that we see here.
You may wonder how this image was made in the first place. Event Horizon Telescope data is like incomplete puzzle set. We actually only see pieces of the real true image. And then we have to fill in these gaps of these missing pieces to construct the physically possible image that is actually matching our data. This is actually a very difficult process. Therefore, the imaging process has been split into several phases. At first, at the very beginning, we were working on this imaging completely alone, each of us. This was a remarkable, almost life-changing experience to see an image of a black hole shadow popping out on the screens of our ordinary laptops. Next, we formed independent teams that work completely independently from each other to repeat the imaging process. This was very necessary, important step because we wanted to get rid of the human bias as much as possible. And in the last phase, which took the longest time, the imaging was done very carefully via very careful scientific analysis. So what have we learned from the images, and not just from the images, also from the data that are lying underneath this image? So first of all, we have observed this source for 4 days. Over the 4 days, the ring is there. The image looks almost exactly the same. We have also measured the size of this ring. Over 4 days, the size is always the same. It doesn't change. We have also measured the contrast between the ring itself and the central darkness. And the contrast is as large as it is expected for the black hole shadow. But there is one more very peculiar thing about this ring. It's not really a full ring. It actually is much brighter at the bottom side. Why is that? our models told us immediately that this kind of structure can be only formed if the source, if something in the source is rotating. What is rotating? It could be the black hole, but also the matter around it, or both can be rotating. At the moment, the images are not yet sharp enough to actually estimate or calculate the exact speed of this rotation, but these images give us a sense of the direction of the rotation, which is clockwise in the sky. So to summarize, our images, our data tell us that we are looking at the shadow of the black hole, which has been predicted by all the models of the black holes that we have developed over the last few decades.